Okay, so I will just repeat again. What we're trying to do this week is to get 2.5 on the list of tasks, which are basic kind of Go exercises. So we're trying to, if someone is at 0.5 now, that's fine, so you covered today. We will do 6 and 7 on Friday. So on Friday we will start with more server-side programming with HTTP and with client-server protocols. So we will do more with the browser and with the backend client, backend application that provides something for the client. But up to number 5, we're just playing with Go with command line and with just simple print line statements. So we're kind of diving into the language. So if I go here, we covered, we went to writing hello world, and we split the hello world into two files, and then we were able to run it to reuse some functions from a different file. So it allows you to organize your project into modules and split within the module, split the logic into multiple files, right? So who is comfortable with that? Yeah, who else? Only one person? 2? 3, 4? Okay. So the rest, please play with it. Play with just simple hello world, like, you know, 4 lines of code. Split it into 2 files and kind of get yourself familiar. There are some quirks. So we just noticed that, like, if you have a single file and if you say go build and that single file, everything works fine. But as soon as you split it into multiple files, you cannot say go build and a single Go file anymore, because then Go will try to compile that one single file and it will not find all the other functions that are in the same module. So you have to say go build dot, which means build everything in the current folder, and then it will work. So you just need to play with it a little bit. I encourage you, even if you're planning to use IDE, I encourage you to use command line for building and running. It will work always. You will be independent of your IDE, and you will get familiar with all the paths and the necessary tools that you need to do for formatting and so on. So use command line for this. Of course, editing files and so on, it's nice with IDE because you have color highlighting and so on. So of course, use it. But make sure that you understand the command line as well, and you can build it from command line. A lot of things that you have to import and do with Go, you will use command line for, and the same with some of the cloud tools that we will use later. I posted 2 videos about setting up IntelliJ and setting up Vim, which I did last year. The Vim is still correct. I just did the setup here locally on the new laptop, and it works fine. The IntelliJ setup kind of works, but the plugins are different. They have different names, and we just experienced that, like, setting up the run configurations is different. And so it's partially wrong, the IntelliJ setup. So I will, at home, I will try to run it myself, and I will give it a try with the Golang ID as well. And I will see if I, you know, I can recommend Golang instead of the IntelliJ. And I will see how you configure the plugins. We were trying to configure it with some of the guys over there, and the configuration was identical. Sometimes it works, sometimes it doesn't. That's the beauty of IDE, yeah? I see. All right. So it should work. The bottom line is it should work. There might be some quirks in your general setup. All right. So moving on, we discuss the modules and discuss the general structure. I can show you some syntax decisions that they did for designing Go. So I will go Yes, I didn't configure my I don't have bash profile at all. Okay. Do I have profile? Nope. So yeah, just give me a second. Yeah, I actually don't need to do that yet, so I will just use a local folder. So I will create a yeah, maybe make it bigger. So I am in my home folder. I will create folder called projects, and I will create a folder called demo1, and we will do yeah, simple main and package main, and we will do some declarations. So if we were to declare a data structure representing a student, for example, we can use a struct. Go has all the normal types like ints and so on. So I can have, yeah, let's do. So I can declare a variable a, which will be of type int, and I can initialize it. So I can say there is a variable a of type int that equals 1, or I can say that there is a variable a that equals 1, and the type will be inferred automatically. So those two lines are kind of equivalent. This is like a declaration with assignment, and this one is the declaration, and then you can do assignment, you know, in the separate line, right? So we have the normal types like ints and so on, but we can also fully qualified names. So if you say that a is an int, how big is a?
32 bits. It depends in your system, I guess.
Exactly. So it kind of depends on the architecture you're running on, right? If you compile it for 32-bit architecture, you will end up with 32 bits integers. If you compile it for 64-bit architecture, you may end up with 64 bits, right?
Also, there is no long.
There is long as well.
Yeah.
But if you want to be specific, you can say 64 or you can say 32, and then you know on all architectures will be exactly the same size, right? Sometimes it matters, sometimes it doesn't matter. So if it doesn't matter, you can stick to the normal non-qualified types, but if it matters to you and you really need the big integers, you say int 64, and then you have the 64 bits integer, even if you're running on the 32-bit architecture. The same with floats and so on. So those types are easy. There is a bool type, same true and false, you know, simple things. And there are structs. So structs and lists, kind of slices, arrays are quite common. So we will do a little bit with structs. So if I want to have a type which represent my student, so I will say I have a student type, which is a struct, and then I can declare what sort of properties the student has. So let's say the student has a name, which is a string, and it has an age, which is an int. Okay. We're doing those examples, but obviously if you were to model a student properly, you would rather have something that cannot be negative and so on. You would like to have like type safety for the age as well. So if you have a function which returns you an age, or functions that accept age, you would like to have some sort of a type safety that you cannot pass, for example, a negative integer to it, right? For the sake of just examples, we don't do it properly. We do a bit of a sloppy job here. So now I have a student type, and I can say that I have S, which is a student, and it has some name and some. So there is Bob, which is 21 years old, right? So we were discussing it earlier that if I set those two letters to be small, then and this one to be capital, the type is kind of exported outside of my module. So somebody using my module can use a student type as well, but then they would not see any properties because I made those kind of hidden. They are package only. So if I were to export them outside, I would have to make them capitalized as well, right? So you have to remember about that. And when we later move on to JSON parsing and working with JSON data structures, you will quite often make your package-specific structure for, let's say, representing a student, which you only use in this one single package, right? But because we use facilities from a different package for parsing JSON and so on, and we're passing those data structures to another module, you will have to make it capitalized, even though you yourself don't use it elsewhere, right? So all the data structure for JSON parsing, you have to keep capitalizing your properties.
So public properties are capitalized?
Public properties are capitalized, public methods and functions are capitalized. Everything that is package specific, which is private, is small letters.
So Pascal casing for public and camel casing for private. If you're concatenating words again.
Yeah, so they use camel casing for both, but they start with a small letter for private properties and package specific things. Okay, so that is quite simple. So what's the difference? So let's say there was one task which was make a student older. So we can accept a student. Okay, and how we can make a student older? We can say that the age is +1, right? Will it work?
No.
Why not?
Students have a big A.
Good. Good typo spotting. So let's say I have print line and we print student age here. And we have to fix our typo. Yes, and we will say make older S, and we print this again. We save it. And we will go build, because I only have one file, I can do this, and I can do this. What do you expect from me running this program?
I'm actually a little bit uncertain.
So we have uncertain people, we have people saying 21, 22. Any other options?
I would say 21, 21 if we're speaking neutral types.
So who thinks 21, 21? Who thinks 21, 22? Okay, I mean there is only one way of knowing, right? Me pressing enter. It's 21, 21. So why it is 21, 21?
That's only the value without passing the reference?
Exactly. So what happens here is this function accepts a student object, It's actually a struct. It's not like object in the sense of Java with methods attached to it. It's just kind of a struct. And then it changes this struct into new value. So if I go here and I say age inside make older, and I say I have a decimal value and it's age, right? So I write that, I build it again, and I run it again. So true enough, yeah, actually that didn't work that well. It prints 22, right? So why this didn't work? Exactly. Very good. I am printing print, and then we would also like to have end of line character. So let's, whoops, come on. Let's see if that fixes the bug that we had. W. Good. Build. Run. Okay, so inside the function, I modified s. So s is modified here. If I inspect s, I modified it. But s here and s here are two different s's, and this one is available here, here, and here. And when I passed it to this function here, what happened? I actually created a new copy of the student instance that got modified. So the modification had nothing to do with the s which we have here. That object which is used here and here is the same object. The object which is passed into the function is a copy of the original, right? So I didn't modify it. So if I write function like this, I actually don't modify the original data structure. I modify the copy. And the copy is modified, but the copy is not returned. The copy doesn't change the original one. So how do I need to fix it to modify the original one? Yeah?
S equals.
Say it again?
Don't you have to set S equals to make older S?
Well, we don't return anything here. Right? That function doesn't return anything.
Can you modify make older to actually return a new student?
Very nice. So we could modify. So one option for us fixing this problem is to say, oops, the function actually returns a student, right? And what we can do is we could say
one down and O.
it could return S actually. So that will work. It's not too nice, but this will work. So if I say, it's like a lot of S's, right? You can get a little bit confused with all the S's that we have here. So let's try that. Okay, let's build this. And it works. Okay, it works, but the code is a bit ugly. So normally when you're coding, you should not reuse variables until it's very obvious that you want to reuse. Like for example, if you have a loop and you're looping through some items, and then you say you have a variable called item that you're looping through, that makes sense to reuse it. But in code like this, it kind of smells if you're reusing S, because you created new S from the old S, right? So it would be nice to say that we actually have new S that is returned, and I'm referencing the new S. So then if I do something with S, I will not mess up my code which touches the new S, right? So I would modify it this way, and the same here. It is kind of, I'm piggybacking on the copy that was passed to me, but what I probably should do, I should probably have a new variable, which is like new student or something, and assign s to that, and then return the new s, right? But I will not do that. So that's one way.
Variable cluttering?
Yeah, it's okay. I mean, the compiler will tidy it up. It's for readability, right? So it kind of, it's easier to follow what is happening, right? Normally, when I'm passing something by value, I don't expect it to be returning that thing, because I will kind of use it inside. It's sort of like a local variable for that method, right? Yeah.
It's more or less normal to make a return value.
Exactly. So then if I am returning something, I will kind of be responsible for creating it, right? Yep.
I was just wondering if you could just pass by reference or send a pointer to
That's
the
right.
memory address.
That's right. So another option of make older version 2 is that we say we actually passing student by reference, right? And then if we use the old code, which was sh equals sh plus 1, and we go back to our original s, so we will say make older 2 s, format print line sh. So now the new s with make older, which returns the copy. So I will just one more thing here. If you did something like this in C or C++, what would happen?
But C actually takes the object as a reference always, so it should be double referencing or something like that.
Will you get the memory leak?
Yes. No, you will not get memory leak. You will get a null pointer exception or some garbage after you finish the call, right? So in C or C++, what happens is all the variables that I create here. So if I have a student, yeah, in C it would be like this, right? So if I have a new s, which is a student, right? And then I assigned, so this is like, yeah, we have to stick to one syntax. So let's see C syntax, okay? So I have new student here, and I'm doing something with new student. I did assignment. I reused the copy of this, for example, into ns. And then in the return, I return ns, right? The moment I quit the closing bracket here, all the memory that I allocated for local variables, including the variables which are the parameters, get garbage collected. They kind of disposed. So I have some space on the stack, which is for my method calls, and I have some variables allocated there. And the moment I return from this method call, the whole stack frame gets garbaged, right? So all those references to all those variables here are garbage, right? To make it non-garbage, I would have to allocate a memory on the heap and return a pointer to that new memory. And then somebody from outside this method can use the heap allocated memory, right? But all the stack allocated memory is just garbage, right?
Well, sort of.
Sort of, more or less. So in Go, as you see here, that doesn't happen. Go doesn't garbage collect everything. It sees, oh, wait a minute, there is a stack variable that I'm actually returning and somebody else is using it, so Go runtime will allocate it on the heap instead on the stack, right? And it will become kind of like a heap allocated memory as if I did new in C++. And then it will keep track of who is using it, and the moment I don't use it anymore, then it will be garbage collected. So there is a little bit magic happening behind the scenes, which makes this code work in Go, but it will not work in C or C++, right?
It should work in C and C++ as well.
Not with the stack allocated variable.
Yeah, because it will copy the contents of the stack to the resulting before it destroys the stack.
Yeah, that's true. Yes. So
that's why I said, yeah.
That is true. So if I returned another student by value, then as he's saying, the copy will be make, and then in the whoever called will get another copy, right? So in fact, we will get like 3 copies along the way, and yeah, that is true. Yeah, that's correct. But if I returned a reference to that stack allocated variable, then it will crash. Then you'll be in trouble. Exactly. Very good point. Everybody understood that?
Sort of.
Sort of. So the difference was, as was well pointed out, if I returned by value also, it would kind of work in C++ as well. But if I returned a pointer to this stack allocated variable, then it would crash. All right, so, okay, will this code compile? Okay, let's try. There is one way of knowing. Just calling the build.
Yep.
Right. Cannot use student because we want a pointer to a student. Okay, fair enough. We are passing student to a function that expects to get a reference to a student. So what should I do?
Take address of the student.
Correct. So as some of you are suggesting, I need to do this. Will this code compile now?
It behaves like C.
It should, right? It does. And if I run it now, what should I get?
21, 22.
I should get 21, then I should get 22, then I should get 22 again because I'm doing the, no, actually,
23.
I'm already 22 at this point, so new student will be 23, right? So I should get 21, 22, 23. Correct? Okay. Works. So when do you need to use things by reference and when do you need to use things by value? Yep.
Externally, I would recommend using things by value consistently. Internally, you could do referencing, but to modify things should only be done internally inside a package.
Yep. So it depends, but the general rule of thumb is as is suggested actually. This method is slightly better in most cases, but it doesn't mean you should only stick to that version, right? But it is good for 2 reasons. One reason is that we have a function which doesn't modify the internal state of our object, right? That kind of is a good property because when you're programming with multiple threads, if you're doing some concurrent processing, functions that modify some internal state, they tend to have issues with race conditions and who got first to data and so on. It's a little bit tricky to debug and a little bit tricky to avoid side effects. So this function doesn't really have side effects. It doesn't modify our original data. It actually takes a copy of it and returns a new copy, right? So it has a kind of a functional feel. So as it is written here, Go has kind of a functional feel. So you can do kind of functions which don't really have side effects, and this style is sort of nicer. But that style feels a little bit more object-oriented because, in fact, I can rewrite this function. So let me try that. I will have a function which operates on student, which is a pointer to a student, and it's called make older, and it doesn't take any parameters, and all it does, it's exactly as it is written below. It does this, and the difference between make older, let's call this one pure, this one make older, and this one make older. So now I have the pure version at the end. I have make older, which accepts the reference to a student, but I can also call it as make older. I can do this. Okay. So the difference between this make older and this make older is kind of, there is no difference. They basically do exactly the same thing. It's just that this one doesn't really take a parameter. In fact, it does. It takes a parameter, which is a reference to a student, but syntactically, I call it kind of like in Java or JavaScript, like in object-oriented fashion. I call s dot make older on s, right? This one I call, yeah, to be actually proper, I have to say this, right? So it says, okay, call make older on the reference of s, right? But that one does exactly the same. So the only difference is syntax, right? Those two functions are the same. They do exactly the same thing. They are operating on the reference of s, of the student, and they modify it. So they have side effects. So let's save it and let's compile it. And now we should have 21, 22. Now 23 is here. And we're making 23 older again. So it should be 24, right? So we're skipping one print. And we have 24. So we're skipping 23, right? Which the s is now. So s now is 23. Okay. About the syntax, because this syntax is a little bit awkward with this ampersand and s. Go can infer what you mean, and you can kind of you can skip this. You can skip that, and you can just say s dot make older. Okay. So if I try to build this, it will compile, and it's equivalent. It's exactly the same. So it builds and does exactly the same thing. It's just that the syntax is a bit nicer, right? Is the syntax a little bit nicer? Well, it is, but if I forgot this star here, okay? So let's say I forgot this star in the declaration of my function, and I build it, and I compile it. The compiler doesn't tell me that I'm doing something wrong. It doesn't warn me about anything. But if I run it, I don't get what I expect. I don't get 24 at the end. I get 23. Why?
Because we are still not sending reference.
We're not operating on the reference. So this one operates on the copy of s, right? This one doesn't operate on the reference of s. And I haven't noticed that, right? I might have, a bug somewhere. And then if I were to expect, so now if I say, if I do this, right? Oops. If I do this, and I try to build, Go is clever and say, probably he means the other thing, right? It's still 23, right? So it converts references to structs and structs to references of structs, depending on what would compile, but not necessarily what I mean, right? So you have to watch that out. So when I was starting with Go, I had lots of problems because I forgot to include the star in some of my declarations, and then I was kind of a debugging nightmare because the compiler and the runtime system will not tell you where your problem is, because all those calls to pointers or structs will work, right? So it makes the syntax nicer, but it makes it debugging harder. You have to pay attention to putting star in appropriate places, right? So you got that? Yeah? You can try. So 1. So we have a number which is an int, right?
I would assume he's talking about the extension, making an extension to an integer where you say add one or increment.
No. So you cannot do that. Why you cannot do that? Because there is a constraint on what you can define methods for. Okay. So when I can do this, I can pass parameters whatever I like this way. This syntax is kind of open for whatever you want, right? This syntax, you can only do methods on type that are declared in the module that you're declaring the functions for, right? So if you declared a student and now I give you my module and you have your own module, you cannot say student dot anything in your module to extend my type, right? So we can only extend the functionality of the structs in the module that the struct is defined. So because I'm not defining int, I cannot extend int. Yeah. But I can, of course, do pointers to ints and pass it in this kind of notation. Yeah. Any other questions for this? Is that so? That works kind of for pointers and for structs, and it's often used. Sometimes you will notice that for some complex data structures, the API Go is using is actually not using a pointer. For example, when you will be doing the tasks like 6 and 7, we use handlers for the input and output of the socket that we're communicating with the web server, right? And one is passed by pointer, but the other one, the writer, is passed by value, right? So you will notice that some of the parameters are kind of passed with with the star, or ampersand. Some are not. So it kind of depends what makes sense. So sometimes we are passing things by value. Sometimes we're passing things by reference. Sometimes copying is okay. Sometimes copying is undesirable. So for example, if I have a very large struct which occupies a lot of memory, and I were to pass it by copying, then you have a performance penalty because you will spend time copying. Same with large arrays, right? So if you have an array, it's much better if you pass them by reference than by value, right? For optimization purposes. So it kind of depends. Most of the time, as I said, that kind of a pure functions are desirable, but you know, if the performance is an issue, then you may opt for doing things by reference. Okay, so let's finish with some lambda functions. Okay, so let's say yeah, let's simplify this. So I will delete some of that. Yeah, so let's have student. Let's have the student age. Oops. Yep, that's fine. So that will work fine. So let's add one more function. So function make something with a student. Okay, and the function make something with a student. Yeah, I know I lost the screen too. We'll take a student, or maybe we actually do that on the reference. Okay. So let's have a reference to a student, and this one doesn't return anything. And what we want is we want to be able to pass a function that will do something with a student. Okay. So what do we need? We need a function called f that takes a student as an argument and returns a student, which then we can apply to our, we can say, actually that will not work that well. We may need to pass a reference, right? So let's do this. Yeah, this is simpler. The other way also would work, but I would have to write more code. So what make will do, make will call f with s, right? Is it kind of clear what is happening here? I have a function which is a higher order function which takes another function as an argument. And then what this function does, it calls this extra function and does something to the student, right? And that's it. So if this new function, which is an argument, doesn't return anything. If it was returning anything, I would have to specify what it returns. So let's say it does return a student, right? So I could say, well, it doesn't matter for me because I'm not returning anything from this function, right? So let's forget about the return types for a moment. Okay, and if I now, what I can do now is I can make our ns. So s is 21, ns is 22, and then what I can do is I can say ns make older pure and print.
Would that work?
No, it will not work. Print line nsh. It will not work because pure doesn't take a reference, right? So it should not compile. Let's try. We have some syntax errors, so I have, yeah. So of course the syntax is, first is the variable name, then it's the type, right? So my variable name is f, and the type of f is a function which takes a reference to a student, right? So let's do this. Let's try to build that. And it says, well, you know, I cannot use make older pure because the function takes a student instead of taking a reference to a student.
Can I ask you a question now?
Yep.
Can you pass ms dot make to make? Would that work? Compile why? Would it compile?
No.
Are you sure?
We can try. It's a very, very bad code.
Good.
Yes, so you cannot use nsmake because nsmake is a function which takes a function.
Yeah. Right.
Good. All right, so but we can take another function which takes a single argument. So I can say I have a function which takes x, and x is of type of what? Reference to student, and it messes up with the student somehow, right? So let's say it says name is Mariusz, okay? Will that work? Whoops.
Should.
So what I did, I just created a new function inside this call to make, which takes one argument, which is a reference to a student, and then changes something inside the student, right? So if I build this, it builds, and if I run it, I will get some numbers and Mariusz at the end, right? So I just changed the name of the student by doing this function. Because this function doesn't have a name, it's just made up on the fly. It's called anonymous function, right? I could make this function named. So I could say, for example, you know, I could say f equals func, and then copy the body, and then say f here, and then my function is bound to a variable. It still doesn't have a name, but you know, at least I can reference it via variable. But if you have, if you have this, you have a higher order function which accepts another function, and then you can do some tricks. So in Go, it's very trivial to write functions which are anonymous, and also very trivial to write lambda functions, and very trivial to return functions at the end, right? So as a task, we had write a function that takes 0 arguments and returns a function that takes 2 arguments and adds them, right? That's pretty straightforward. So if I were to do that, to do this, let's do that at the end. So I need a function which doesn't take any arguments and returns a function which takes 2 arguments, let's say and y, which are ints, and the function which this return and this one returns an int. And then what I need to do is I need to return a new function that takes x and y, which are ints, and returns x plus y, right? And now I can call it, right? So if I call it here, I will get the function which takes 2 arguments. So now I can call it with you know, 10 and 20, and I will get
this could be messy quick.
it doesn't complain about indentation, surprisingly. Yeah. Okay, so so cannot use okay. So
I think the function below doesn't return an int. 1 down and past the end parent there.
Maybe behind it.
yes, correct. Excellent. So now it will work. It will print 30 at the end. What we did, we declared a new function which returns a function. The original function doesn't take any arguments, so that's why we're calling it with no arguments. And the second function, which this one returns, is a function which takes 2 arguments, and we're calling it after we declared it with those 2 arguments and returning the 30, which is the sum, right? You can try to write this in C++ with lambdas as well. But this is an ugly syntax. I mean, it's not super readable. I mean, it's relatively readable, but it's not that readable. But in C++, it gets even less readable, right? So there are some limits to how much, you know, nested function declarations can be. Of course, to make it kind of clearer, what we should do is we should declare the functions kind of up, you know, with some variables, for example. Yeah?
Do you have any good indicator, or are there any benefits of having nested functions in that way?
Well, I mean, that was a very contrived example, right?
Yeah.
But where we do use it? We use it when we need, for example, some decorators. When we will be using with web services, you usually have a handler which handles some incoming traffic and produces some output, right? And this is built as a function which takes 2 parameters, right? And then suddenly you need a logger right? So what you can do is you can have a higher order function which takes this function as an argument and generates a new function which you plug into your, you know.
Okay, so when you are modifying
Exactly.
method,
when you want to
in
decorate the
return
behavior.
same kind of
Yes,
method.
exactly, exactly. And then it becomes very useful.
Yeah,
So there are some
yeah.
patterns where you will use it. For this case, obviously, you know, that's as I was explaining earlier, we're using very contrived examples to explain something, but you wouldn't be doing things like that when you don't need to, right? Yeah.
So if I had a log function that would wrap around make older pure. for
Exactly,
instance.
exactly.
Okay.
So when you want to see who is, you know, making students older, you would have a wrapper function which kind of does that. Yeah. That's the whole point. All right. So as a homework, you can rewrite it in C++ and see whether it's more readable. Okay, we kind of done here. So I still have. We've done the object-oriented modeling. You can model object-oriented classes using structs and methods on top of structs. You can use higher-order functions. So we've done some things. We can try to do some of those series and so on at home. What I will talk on Friday about, which we haven't talked about, is concurrency. So I will talk a little bit. Yeah, we've done this already. We've done this. We haven't talked about interfaces. So on Friday I will talk a little bit about interfaces and about concurrency. And then we will move on to doing the web programming using the streams, which are relatively straightforward as well. So that's it for now. So we kind of almost at 0.5, but not quite. Okay, so thank you.